Hi all of you, my name is Nishant and welcome to this tips and tricks class on number system. This is a revision or a recap class and I hope that you have watched the previous videos in which we have covered number system. In fact, we have done number system very extensively in recordings of over 6 classes of over 10 hours duration, because this is a chapter that has multiple components, multiple concepts, and we have covered them extensively in our classes. So I strongly recommend you to watch those classes first, and then this class can be used more of a refresher or more of a revision before your exam or when you want to revise everything in quick time. Okay, so here we are going to go through the concepts slightly faster. We will look at the concepts, we'll look at faster and shorter methods of solving the questions, and we'll take up some high level problems as well. In case you have doubt in any part or you want more detail, I suggest you and strongly recommend you that you go back to the original video where the class has been taken in detail, and then you can get more clarity there. Okay, so let's get moving. Now, basic number system obviously starts with classification of numbers. We classify numbers into two types. As you can see here, we have real numbers and we have imaginary numbers. Okay, and when you combine real and imaginary numbers, you get a complex number. Now, what is the imaginary number? How do you define imaginary number? You know that you cannot have square root of a negative number, right? So if I take a number I square is equal to -1, this you know is theoretically not possible, and hence it becomes imaginary. So we introduce a term called I, which is under root of -1, and any number which has I attached to it, for example 5i, 7i, 10i, this is what we call as an imaginary number. Okay, and if I combine real and imaginary numbers, then you get a number which is called a complex number. For example, 3 and plus 5i. Now 3 plus 5i, you can see this has a real component and this has an imaginary component, and hence this is called a complex number. So complex number gets by combining real and imaginary numbers. Okay, but we'll not focus on that there, because normally your MBA exams will not ask you imaginary number or complex number based questions. So let's focus on the next part, which is rational and irrational numbers. A very important concept. Rational number is a number which gets defined as any number that can be written in the form p by q, where p and q are integers. Okay, p and q are integers and q is not equal to 0. So any number that can be written in the form p by q, where p and q are integers and q is not equal to 0, is defined as a rational number. When a number is in a fraction format, and if the number is in a decimal format, then we say that your decimal, basically if you see, your decimal can be of two types. It can either be a terminating decimal or it can be a non-terminating decimal. What do I mean by terminating? Any decimal that gets over. For example, 2.37. This is a terminating decimal. It gets over. Any terminating decimal is always rational. Okay. Any non-terminating can be of two types. Non-terminating means it does not get over. For example, 2.373737, this goes on till infinity. So this can be written as 2.37 bar. Okay. Or let's say the whole of it does not repeat. 2.371, 71 repeats, 3 does not repeat. Either of the cases, these will be called as recurring. So they are recurring. They are non-terminating, but they are recurring. Okay, and remember that recurring decimals are also rational. Then we are left with the third type, which is non-terminating and non-recurring. So they are non-terminating as well as non-recurring. For example, I have 3.172947321. It just goes on. It goes on and it does not repeat also. So non-terminating and non-recurring, these numbers are irrational numbers. Okay, what are the common irrational numbers that we use? One irrational number which all of you will know is pi. Pi, if you see most of the books, it will be mentioned as this is equivalent to 2 by 7. This symbol, if you see, this is equivalent to, this is not a equal to. So pi is made equivalent to 22 by 7, because the moment you see 22 by 7, you will say that this is a rational number. It is of the type p by q. But no, this is equivalent to, the exact value of pi is slightly more complicated and it's actually irrational. So we take it as 22 by 7 to be able to solve questions. But otherwise pi is an irrational number. Okay. Similarly, your Euler's number is an irrational number, E, which we use in log a lot of times, log to the base E. This E also is irrational number. And in fact, between every two rational numbers, there are infinite number of irrational numbers. Okay, so let's say you take 3 and 4. Between 3 and 4, there are infinite number of irrational numbers. In fact, most of your roots, which are not perfect roots, are irrational number. Okay, so your root 3, root 4 will not be, but root 5, root 6, root 7, and not only root, third root, fourth root, fifth root, sixth root, seventh root, all this will give you irrational numbers. Okay. Also, you should know one more small thing, that in case you have to convert, let me erase the whole thing. In case you have a number, let's say 0.23 bar, this is a recurring decimal, and this you have to convert to a fraction form. Always remember that this is equal to 23 upon 99. You just have to remove the recurring symbol, and two digits are recurring, so you put 2 9s in the denominator, so this number is equal to 23 upon 99. And a slightly more complicated variety is if I have 0.237, where 37 is recurring, 2 is not recurring. So this number as a fraction will be 237 minus 2 upon 990. Okay, how 237 is the decimal part, 2 is the non-recurring part. So from the whole decimal part, you just subtract the non-recurring part. There are 2 recurring digits, so you put 2 9s, 1 9 for every recurring digit. There is one non-recurring digit, so you put a 0 for a non-recurring digit. So that's how your recurring decimals can be converted to fractions. Okay. So let's go further down. Rational numbers are fractional numbers and integers. Your fractions are of 3 types. You have a fraction a by b, where a is less than b. This is called a proper fraction. A is greater than b is called a improper fraction. Okay. So for example, 1 by 2 is a proper fraction. 3 by 2 is an improper fraction. And 3 by 2 can also be written as 1 by 2. So this is not a third type, but it is another type of writing an improper fraction, and this is called a mixed fraction. Okay, so we have proper, improper, and mixed fractions. Okay, that's one part, and the second part is integers. Okay, so from minus infinity to minus 1 to 0 to plus 1 to plus infinity, all these are integers. Integers can be divided into negative numbers, 0 and positive integers. Be careful here, 0 is not a negative integer, 0 is not a positive integer, 0 is a separate category by itself. Okay, and if you take 0 and the positive integers together, they are called whole numbers. If you take only the positive numbers, then they are called as natural numbers. Okay. Then further, your natural numbers can be divided into even and odd numbers. That is one classification. They are also divided into prime and composite numbers. That is the second classification. Even and odd, I don't have to tell you. You know that already. But for prime and composite, how do you define a prime number? A prime number is a number that has only 2 factors. Okay. For example, number 7. 7 can be divided by 1 and 7. So it has 2 factors. Hence, it's a prime number. But if you look at number 6 can be divided by 1, 2, 3 and 6. Hence it's a composite number. Okay. So any number which divides a given number completely is called a factor. So a prime number will have only 2 factors. A composite number will have more than 2 factors. That means minimum 3 factors. Now you may ask me, what about 1? 1 has only 1 factor. Okay. So 1 is called neither prime nor composite. It is called a unique number. Okay. 1 is a unique number. It is neither prime nor composite. The only even prime number is 2. All other prime numbers are odd. And 1 to 100, there are 25 prime numbers. 1 to 50, there are 15 prime numbers. Okay. All prime numbers are of the type 6n plus minus 1. But all numbers of this type may not be prime. So it is a necessary condition, but it is not a sufficient condition for a number to be prime. How do you check whether a number is prime or not? There is no real formula for that. What you will have to do is you will have to take an approximate square root of the number. Let's say I give you a number 300. Now 300, you will have to take an approximate square root. What do I mean by approximate square root? Take the closest integer. So 300. Now you know 16 square is 256. Right? What is 17 square? 17 square is 7 to 7, 49, 9, 4 carry. So we have 7, 14, 4, 18, you have 289. Okay, so 18 square will cross 300. Okay, so this will be more than 300. So I take 17 and then I check the divisibility of 300 with all numbers from 1 to 17. And if 300 is divisible by any number between 1 to 17, then it's a prime number. It's a composite number. Otherwise, it's a prime number. Okay, so that is the method that you'll have to use. Okay, so I hope we are clear with the definitions of these. Of course, in subsequent slides, we will go more in detail on prime and composite numbers. Okay, let's move forward. Let's start with properties of divisibility or rules of divisibility. Okay, we'll come to that. Before that, let's look at the property. Very simple concept. If A is divisible by B, if any number A is divisible by B, then AC, so you multiply A with any other number, that will also be divisible by B. Okay, for example, let's say 10 is divisible by 5. Okay, then 10 you multiply with anything, that will also be divisible by 5. Then second part is if A is divisible by B and B is divisible by C. So let's say we have 20. 20 is divisible by 10. 10 is divisible by 5. Then that implies that 20 will be divisible by 5 as well. Okay, that is the second rule. All fairly basic, but a recap is always better before we jump into more deeper concepts. A and B, if A and B are natural numbers such that A is divisible by B and B is divisible by A, then obviously A is equal to B. 20 is divisible by 20, then they have to be same. Okay, if A and B are independently divisible by N, that is, let's say 20 is divisible by 10 and 30 is also divisible by 10, then 20 plus 30, which is 50, will be divisible by 10, and 30 minus 20, which is 10, will also be divisible by N. So that is the fourth one. And fifth is, if A is divisible by B and C is divisible by D, so 20 is divisible by 10, 8 is divisible by 4, then I can multiply the dividends as well as the divisors. 20 into 8, 160 will be divisible by 40. Okay, so these are few basics that we should be clear with. And then let's move to rules of divisibility. Okay, so in rules of divisibility, let's first look at number 2. Number 2 has a very unique rule that for number 2, you check the last digit. Okay, good thing with number 2 is that this rule applies not only to number 2, but for number 4 as well, number 8 as well, number 16 as well. Okay, so basically all these 2, 4, 8, 16, they are what? They are powers of 2. So regular rule is that whatever is the power of n, 2 to the power n, you check last n digits. That means for 2 to the power 1, you check 1 digit. For 2 square, which is 4, you check last 2 digits. For 2 cube, which is 8, you check last 3 digits. For 2 to the power 4, which is 16, you check last 4 digits, and so on. Okay, so this one rule actually takes care of so many numbers. And same rule also applies for 5 to the power n and also 10 to the power n. Okay, so this, and this. All these are same rule, 2 to the power n, 5 to the power n, 10 to the power n. For all of them, you check last n digits. Okay, so 2, 4, 5, 8, 10, so many numbers taken care of in one rule. Then we have the rule for number 3. For 3, you check the sum of the digits. And good thing again here is that this rule is not only for 3 but for all powers of 3. So it is sum of digits. As you can see, sum of the digits should be divisible by 3 to the power n. Okay, so let's say if I have a number 1, 2, 3, 4, 5. I want to check divisibility by 3. I will add all the digits. I get 15, and because 15 is divisible by 3, the number is divisible by 3. If you want to check the divisibility by 3 square, which is 9, the rule is same. You check still the total is 15. 15 is not divisible by 9, hence the number is not divisible. Good thing is that these rules do not only tell you whether it is divisible or not, they also tell you the remainder in case it is not divisible. So for example, this 2 to the power n that we saw, let's say my number is 1, 2, 3, 4, 5, same number. I want to check the divisibility by 2. I check the last digit, which is 5. 5 I divide by 2, I'll get a remainder of 1. Okay, so in case of 2, my remainder is 1. In case you want to check for 4, you check the last 2 digits, you get 45. 45 divided by 4 gives you a remainder of 1. In case you want to check for 8, you divide the last 3 digits, which is 345, and 345 you'll see, you'll still get 320 plus 24, 344, you'll still get a remainder of 1. Okay, so if it is not divisible, you get a remainder also, and same applies for 3 as well. So 15, if I divide by 9, I get a remainder of 6. So it tells you whether it is divisible or not, and in case it is not divisible, it gives you remainder as well. Okay, so that is the rule for number 3. 3 and powers of 3. So it takes care of 3, 9, 27 and all those numbers. Okay, so we have done 2, we have done 3, we have done 4, we have done 5, then we have done 8, we have done 10, then we have done 16, we have done 25, we have also done 9, we have done 25. So all these numbers done. Now 6 is missing in between and 7 is missing. Okay, now 6 is a composite number, and composite numbers do not have their rules of their own. 6 is basically 2 into 3. So for 6, you'll apply rule for 2 and also for 3. So as simple as that. Okay, so 6 need not have a rule of its own, 12 will not have a rule of its own, 14 will not have a rule of its own, 15 will not have a rule of its own. Okay, so all the composite numbers you basically break into prime factors and you apply the rule of the factors. Okay, then we are left with number 11 and number 7. Now 11 has an interesting rule. 11 basically says sum of the digits in the odd position and sum of the digits in the even position, and you take the difference. Okay, so this and this you subtract, and that difference should be divisible by 11. Okay, so let's take a slightly bigger number. I have 1, 2, 3, 4, 5, 6, 7. Okay, so I add the odd digits, which is 1, 3, 5, 7. 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16, and I add 2, 4, 6. 2, 4, 6 gives me 12. So minus 12, you get 4. Now this should have been 0, or it should have been a multiple of 11. So this should have been divisible by 11. Because it is not divisible, that means this number is not divisible by 11. Okay, so rule for 11 is very simple. Then we have rule for the remaining numbers, which is 7, 13, 17 and 19. These rules are empirical rules or derived rules. Okay, when I say derived rules, what I mean is these are not exactly rules, but they have been made, and if required you can use them. Okay, and they work well, they work pretty well. Okay, but it's empirical, so it's slightly iterative. Okay, so what happens, I'll give you one example and then I'll just tell you the others. Let's look at 7. So let's say I have a number, I take a number 3, 5, 1, 4, let's say, and I want to check whether this is divisible by 7 or not. So the rule is you remove the last digit. Okay, you double the last digit. So last digit is 4, you remove 4, you double 4, that 8, and you subtract it from the remaining number. So 351 minus 8, that will give you 343. Now 343 is divisible by 7 or not? If you know, very good. If you do not know, repeat the same step. Remove the last digit, double the last digit and subtract it from the remaining numbers. You get 28. Now 28, you know that is divisible by 7. So you can keep repeating the steps till you get a single or a double digit number where you are aware that the number is divisible or not. So basically remove the last digit, double the last digit, subtract the last digit. So that's why we say x minus 2y. Okay, minus, subtract and double. 13, the rule is same except that you make it 4 times and you add. 17, you make it 5 times and you subtract. 19, you make it 2 times and you add. Okay, so you can see that whether you add or subtract and what you multiply with, that is different. Otherwise the steps are same. So as I said, these are empirical. If required, you can use them. Otherwise we can most of the times manually calculate. Okay, so we have understood the concept. Now let's look at some questions. So the first question here says, let n be the number of different 5-digit numbers divisible by 36 with the digits 1, 2, 3, 4, 5 and 6, no digit being repeated in the numbers. What is the value of n? Okay, so I am checking the divisibility by number 36. 36 is what? 36 is equal to 4 into 9. So I'll apply the rule of divisibility of 4 and I'll apply the rule for 9. Okay, when we look at powers of 3, then you know that the rule is sum of the digits. Now sum of the digits is a very strong concept because the sum does not depend on the sequence of the numbers. What I mean by sequence is you have to select 5 out of these 6, right? So 6C5, you can select them in 6 ways. Okay, and then you can arrange them because this is a number. After you have selected 5, you also can arrange them. So in fact, you can arrange them in 5 factorial ways. Okay, so actually the number of numbers that you can form is 6 factorial, which is 720 numbers can be formed, which is obviously massive. Okay, so it is not important that what I select. What is important is the total, which is the rule of 9. So if you see, the minimum possible total of the 5 numbers will be 1, 2, 3, 4, 5, which is 15. And the maximum possible total of the 5 numbers will be 2, 3, 4, 5, 6, which is 15 plus 6, 21, minus 1, 20. So your total will be between 15 to 20. Now the only number, only sum between 15 to 20, which is divisible by 9, is a total of 18. 18 is the only possible sum, that is a multiple of 9. So now for 18, if you take all these 6 numbers, they add up to 21, right? So they add up to 21, but you want a total of 18. That means number 3 you should ignore. So my digits have to be 1, 2, 4, 5 and 6. This is the first one, which is applying the rule of 9. I want total of 18. My 6 digits give me a total of 21. I need 18, so I have to subtract 3. That means 3 is the number that I should let go. So 1, 2, 4, 5, 6 are my digits. Now the beauty of 9, as I told you, is no matter how you arrange them, it will always be divisible by 9. Okay, because 3 and power of 3 are only concerned with the digits, not with their position. But coming to number 4, 4 is concerned with, of course, the position. It depends on the last 2 digits. Last 2 digits should be divisible by 4. So if you look at here, the smallest possible ending can be 12. Okay, after 12, you can have 16. Okay, you can't have 20, but you can have 24. You can't have 28, but you can have 30. No, 3 is not there. You can't have 32. Then we move to 40. You can't have 40. You can't have 44. You can't have 48. You can have 52. Okay, so after 30s, we had to skip 40. We couldn't have 44, 48, so 52. Then you can have 56. 60 you can't have. You can have 64. And 64 is the largest one. So 1, 2, 3, 4, 5, 6. So when I say 12, it means it should end with 12. And then there are 3 more places here. Okay, similarly in all these cases, 1, 2, 3, 4, 5, 6 cases, your last 2 places can be filled in 6 ways. Okay, and then before that, the 3 places, there are no rules. So when you select 2 digits, 3 digits are left. So 3 digits can be arranged in 3 into 2 into 1 way. Last 2 places can be arranged in 6 ways. So you have 6 into 6. There are 36 numbers which can be formed. Okay, which will be divisible by 36. Okay, so that is the answer, and this is how this question will get solved. Okay, let's look at one more question. A number is formed by writing the first 54 natural numbers next to each other like this. Find the remainder when this number is divided by 8. Okay, divided by 8. So when you're dividing by 8, 8 you know is 2 cube. For 2 cube, you look at last 3 digits. So not very complicated. You just have to bother about the last 3 digits. And it is first 54 natural numbers. So ending will be 53, 54. So last 3 digits will be 354, right? And 354, if you divide by 8, you can see 32 will be divisible. 32, then you'll have 3, you'll have 34, again 32 will be divisible. you will get a remainder of 2. Hence your answer will be third choice. Okay, that's all that you have to do here, nothing extra, because by 8 you just have to check the last 3 digits. Okay, let's move on. We have one more number. If this number is divisible by 72, then what is the sum of a plus b? These type of questions are very common in CAT because a plus b, so you can't reverse calculate. You can't use the options to give the answer. Okay, divisible by 72. 72 is what? 72 is 9 into 8, right? 72 is 9 into 8, so I'll have to apply the rule of 9 and also for 8. Okay, what is the rule for 8? Let's apply 8 first. 8 is last 3 digits. So last 3 digits is 96b. This has to be divisible by 8. So obviously b can be 0 because 960 is fully divisible by 8, or b can be 8 also. So as per the rule of 8, b can be 0 or 8. You get 2 cases. Okay. Then we have the rule for 9. 9 is sum of the digits. Let's look at the sum. 7 plus 7, 14, 14 plus 4, 18, 18 plus 9 is 27, plus 5, 32, plus 8, 40, 49, 55. So it is 55 plus a plus b. And this has to be divisible by 9. Okay, let's take cases of b 0 in 8. If b is 0, then it is 55 plus a, and if b is 8, then it is 55 plus 8, 63 plus a. Right? This is the case when b is 0, and this is the case when my b is 8. Okay. Now this has to be, these totals have to be a multiple of 9. For this to be a multiple of 9, your 9 into 6 is 54, 9 into 7 is 63. For 63, your a has to be 8. Nothing else. Only possible is a is 8. Right? And the positions also are fixed. So a is 8 and b is 0. This is one possible combination. So a plus b is equal to 8, which is given to me in the answer. Most likely that should be the answer. And the second case, let's look at the second case. Second case is 63 plus a. Now you know 63 itself is a multiple of 9. This also is 63 plus a. So one value possible obviously is 63. Okay, which is possible only if b is equal to 0. A is equal to 0. So a is 0, b is 8. That again gives you a total of 8. And another possibility is 72. Right? For 72, a should be 9. If a is 9, then 63 plus 9 is 72. So b is 8 and a is 9 is also possible. So a plus b will be equal to 17. Okay, so this is also possible, but 17 is not given to you in the answer. Hence, we will go with the number 8. Okay, so this is the answer for this question. Great. Let's look at one more question. Let S be the set of positive integers such that every element n of S satisfies the condition that n is between 1000 and 1200. Every digit in n is odd. Every digit is odd. Okay. Then how many elements of S are divisible by 3? Okay. Now if you see, if every digit is odd, then from 1000 to 1099, actually there is no number possible because the third place will be 0 throughout. So in fact, all these 100 numbers are ruled out. Even 1200 can't be there. So only numbers that we have to take are from 1100 to 1199. And here also we have to take only where every number is odd. So 1100 and up to 1109 also nothing is possible because 0 will be at the tens place. So in fact, the first number that will be there is 1111. Right? So from here, if you see, it has to be divisible by 3. Okay, so 1111 gives you a total of 4, which obviously is not possible. Then you will have, so here after this you'll have 1113, 1115, 1117 and 1119. Right? So this total is 4. It increases by 2. So this total is 6. 6 total is fine, right? So this is a number which is divisible by 3. Then 15. 15 will give you total of 8, this will give you total of 10, and this will give you total of 12. So 12 also is fine. So you get two numbers, 11, 13 and 11, 19. Okay, then 11, 20 series you can ignore. Then we come to 11, 30 series, 11, 31. This gives you a total of 6. Okay, so this is a number. Okay, then you have 11, 33. Total will increase by 2, remember. So 6 will become 8, 8 will become 10, 10 will become 12. Okay, so 33, 35, 37. So 1137. So here also you get two numbers. So you can see that wherever we are getting, we'll get two numbers. Okay, 1140 you can ignore, 1150. First number is 1151. Okay, which gives you a total of 8. So no. Then your 53 will give you total of 10. 55 will give you total of 12, which is what we wanted. Then 57, 59. Okay, so 57 will actually give you 14. This will give you 16. So you actually will get only one number, 1155. Okay, then 1160 you can ignore. In 1170, first number is 1171, which gives you 10. 73 will be there, which will be 12. Then 14, 16 and 18. So this is 75, this is 77 and this is 79. So 1179. Okay, so I get two numbers here, 1173 and 1179. And then 1190 series, 1191. This gives you a total of 12. So you'll get two numbers here. Then 93, 95, 97 should be. So 14, 16 and 18. So yes, 1197 and 1191. Okay, so how many numbers? We have in the first series two numbers, 4, 1, 5, 2, 6, 7 and 2, 8, 9. So you have 9 numbers where all the digits are odd. The number is between 1000 to 1200 and they are divisible by 3. So this gives you the answer here. Okay, so that is how this will get solved. We have got 2 everywhere except for the 50 series where we have got only one number. So 2, 2, 2, 2 and 1, total of 9.